Hello everyone, and this is our first machine learning related tutorials video. It's going to be a series, and I'll show you the software side of the machine learning. Eventually, we're gonna build all these models, but I will show you how a common business, especially from small to medium enterprises who doesn't have much data, how they can leverage the machine learning in these days and how they can benefit from it. So because there are a lot of misconception in terms of what we are seeing on all these demos from big companies from the software perspective, but what the ground facts are, that's something we need to be very clear once we are working within the machine learning environment. Like I think I have mentioned about me in another video. A quick introduction: I have more than 15 years collected experience working with data from the database application perspective, all the way to the data warehouse, data science, solution development, nationally and internationally. Within Australia, outside of Australia, I work with government agencies, not for profit, private organization, and during that time, I work on a lot of projects, and that involves a lot of integrations, machine learning work, as well as actually the major focus was on the data. And if I tell you, if you listen to all the practitioners who are working within the data sciences or machine learning in this age, they are all concerned about the data, and most of the time they work to prepare the data, and that preparation involves a lot of stuff. We are not going to look into it. We will look into in the upcoming video. But what's the concept of this video, which I want to clarify? What's the difference between traditional programming and the machine learning, and how you can identify whether you are working in a programming paradigm or you're working in the machine learning. So let's first start with the programming. Normally in the traditional programming, and let me draw a line so I can put both on my screen side by side. So normally in the traditional programming, we receive some logic as a business requirement, and normally in the business analysis time we called it business logic. And in our applications, we apply this business logic, and based on the logic, the system will execute and generate some sort of output. Now, let me take a very simple example of two variables. One is age, and the other one is age group. And I think it's better to call it age range. So what we're gonna do, we got a business rule that if the age range is less than equal to 12, then age group is child. Else, if age range is greater than 12 and age range is less than equal to 19, the age group will be teen. All right. So that's a typical programming side, which we work on day-to-day basis, and that covers the application development, database development, and you can name it whatever you want. All, especially all the development side is based on this sort of, I would say, paradigm, or this sort of logic that we use in our traditional programming. Let me write it down, programming. All right. Now, in the machine learning, there is a clear difference. We don't put the condition. So keep in mind, we are not going to put any hard code condition. What we are going to do, we will feed the data, and based on that data, system will learn and generate a prediction. Now that sounds interesting. So we have three steps. First, there is no condition, hardcore condition in our machine learning solution. We always work on the data. So that tells us that first, the machine learning is heavily depending upon data. So whenever you go in the market or you listen to any conference, and they are showing you any machine learning solution or the new algorithm, always keep in back of your mind that you need to make sure your data is ready before you apply that solution or the new algorithm or model. We have seen many projects fail in the industry just because they think they can buy off the shelf product and they can implement and it will solve all their problem, but the reality is different. That's the first thing. Secondly, we know that we're going to feed the data and machine will give us some sort of output. So that means that output will not be 100%. Because if that output will be 100% in terms of accuracy, that means we have done something amazing, which is not possible in reality. It's more like an ideal condition which we are talking in the text. But practical side, if you are achieving, I would say 80 to 90, that's a really great result, tell you the truth. Now, the last thing, system will learn based on the data, and it will generate some sort of prediction or some sort of output, which actually equivalent to our conditional part in our programming language. So now you can see what's the clear difference. So I need to take an example, but unfortunately the screen is filled up. So what I'm gonna do, let me see if I can put a new screen, and I will take the screenshot of this so we can use it. We can use it later. So let me take the screenshot. I have that screenshot, and now let me share a new. Okay. So now we are going to see the machine learning in terms of the example. So like I mentioned, so what we are going to do, we use the same variable, age range, and we have age group. But this time, and if I just draw this data, so for example, if I have a point, and one thing in machine learning, each record or each variable or combination of a variable refer to a point. And because we are talking about data, so we called it data point. So for example, in this example, if we have some sort of data set, or I would say some sort of examples. So for example, we have 5, 7, 10, 12, 15. And we say that 5 is child, And imagine we are using the same example, so we can clearly see the difference between programming and the machine learning. Child, 10 is child, 12 is child, and but 15 is going to be teen, 19 is going to be teen, right? So just keep in mind that that's the data point which that's the data set we have. If I try to draw it, so if you don't know the geometry, that's all right. Just keep in your mind that once we draw the data points, they are in some sort of space. And what does it mean? Each data point have some sort of attributes, right? So for example, if I take the first record, that's going to be 5 and child. If I take another one, that's going to be 5 and child. So in machine learning, normally what we do, because we need to draw the data to just to understand how this data looks like. So because if you remember, I said that we predict the output. It's not like we calculate the output or we generate the output. We always predict, and that output can be 100% sometime, or that output can be 50% accurate. It really depends upon the algorithm and the quality of the data. So what I'm going to do to keep things simple, I'm just going to label these age groups in numeric, so I can show you how we can draw this data. So I can say if age group is child, it is 1. If age group is teen, it is 2, and on and on. It's more like a mapping, and we will discuss mapping once we go further in our machine learning, right? And now if I come in here and I draw this point, so for example, we have age from 0, 1, 2, all the way 5, blah, 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 all the way 20, right? And then we have age group 1 for kids, 2 for teen, 3 for, I would say, adult, 5 for mid-age, and let me write down 1, 2, 3, 4, right? And that's going to cover. So if I take my first example, it will be somewhere because it is 5 and 1. So that point is going to be in here. So that is showing my first record. If I'm going to take 7, that's going to be in here. And it's going to be also child. So that will be in here, 7, 1, right? And just keep in mind 1 is equal to child and 2 is equal to teen. How these mapping work, that's a separate lecture we will discuss separately, but it's for the timing, just consider these are the mapping. We consider child is equal to code 1 and teen is equal to code 2, right? Now, so that's how we design the model, and now we are ready to predict any new records or any new I would say point or record comes in which we have no idea which age group it's going to belong to. And just keep in your mind, we are not putting any if else condition. So that means any point comes into the system, and based on that based on our existing data, we're gonna identify which category it lies in. So if I take an example of 4, and let me change the color to a different one. So for example, I have a question that, okay, predict. And remember, I'm not saying find, predict. What's going to be the label for age of 4? So we have a record, and we need to find out or predict what's the age group. So if I come in here and if I draw this point, that point is going to be closer to 5. And I would say at the moment it is in here, right? Now, I don't know what's the label of 4, but I know the point which it is closer to has a label of child. So 0.5, it is the label as 1, which is equivalent to child. And that's my 4, which I want to find out. So what I can say, and one more thing, if I compare, because I have another category called 2, which is I would say starting from here, and let me put that one in here as well, because it is starting from 13, because the business logic based on that is saying 13, but we are not, because we are not implementing any if-else condition. But I know that from 13, we have a point which is showing us a category of 2, right? Now on this graph, you can clearly see the distance between 4 and 5 is 1, but the distance between 4 and 13 is going to be, if we subtracted, 9. So that means that this new record, which has unknown age group label, this record is closer to 0.5 compared to 13. So what we'll say that this label or this new record should have a label of 1. So let me put it 1. And if I put it in here, 1, so that's going to be this point 4,1, and based on that calculation, we predict that this is going to be a child. So that's how machine learning works. I know it's not straightforward, but that's how. But the best part of the machine learning, that you can see that machine is learning from the data. So the more data it has, it will help machine learning to identify the label which we are interested in finding out. So that hopefully, let me bring back now, let me take this snapshot of this screen as well, and then we put both screens side by side so we can do some sort of comparison to finalize this video. All right. So what I did after explaining both, I put both sides side by side so you can see the difference by yourself. What we're gonna do in the next video, we're gonna see it practically once we implement, and I'll show you how a normal programming solution works once we are building a solution, and how the machine learning solution looks like from the practical perspective. But I think this screen is clearly showing you, we are on one side we have the hard-coded logic, on the other side we have the data point, and based on the data points, machine will identify the upcoming or new data, and that's a typical, I would say, a clear and major difference between machine learning solution and programming solution. So whenever you are building a solution, keep this in mind. When your solution is relying on the data, that means your solution is a pure machine learning solution or data science solution. And if you have hard-coded condition in your program that is covering a lot of aspects, then the solution is, I would say, switching or slipping from machine learning side to programming side. Hopefully, this video will be helpful and clarify a lot of doubts between programming and machine learning. If you like the video, please like and subscribe the channel to see more videos. And I'll see you in the next video. Thanks for watching. Thank you.